In the previous video, we considered the ambiguous case. The ambiguous case is when you can have a triangle as long as AC and AC are identical and AB and AB are identical. Then we know that there's two angles that can pop out, either 50 degrees or 130 degrees, that have exactly the same area of 7.66. So in this case here, we need to use the NRAT area to solve for the unknown angle. Okay, find x correct to one decimal place. Now what we're going to do in this case is not use our ClassPad solve, we're going to use our knowledge of supplementary angles to help us solve this. So our first step is just to label our triangle, as we always do. Okay, so we go A, B, C, small a, small b, small c. Our next step is to just find our formula. Well, we're going to use our sine A formula, so area is equal to half BC sine A, subbing what we know. 7 is the area, times by half, times by b, which is 5, times by c, which is 4, times by sine of x. Okay, now what we're going to do is we're going to pretend that we don't know our solve function here. So let's just say your ClassPad breaks on the day, or you only have a scientific calculator. So we're going to rearrange this. We're going to solve for x by rearranging. Firstly, so we've got half times by 5 times by 4. Well, 5 times 4 is 20. Half of that is 10, right? So we know that if we want to get this by itself, it's going to be 7 divided by 10 is equal to sine of x. Now, how do we get x by itself in that case? So let's let that load up. Okay, is when you take the inverse sign to cancel out the signs, right? So we just have x is equal to inverse sine 7 on 10. Now, we're just going to look at the acute case in this case. So let's see what happens if I type in my calculator inverse sine, shift divide for that little fraction button, which is always so helpful, on 10, close our bracket, and we get 44.43 degrees. Now hang on, I know from the previous example that there should be two angles popping out of this, right? Or there could be two angles popping out of this. Well, do you remember how we looked at the fact that a supplementary angle, so sine 44.43 has a supplementary angle? So let's have a look. We know that sine 44.43 degrees is also equal to sine 180 minus 44.43 degrees. Okay, so let's have a look at that. 180 minus 44.43 degrees is 135.57 degrees. So we know that sine 44.43 degrees is also equal to sine and 135.57 degrees. Okay, hang on. So therefore, I don't have one answer, I've just got two answers popping out. Because both of these are reasonable, right? I can absolutely have both of these. So I want to put both of these answers down and confirm with my ClassPad. So we've already shown it down here. So solve 7, which is up here, is equal to 10, which is half of 20. Sine x, given that x is our variable, given that x has to be an obtuse or acute to obtuse angle. We get two answers popping out. The ClassPad's telling us is either 135.57 degrees or 44.43, right? So your ClassPad can do this for you straight up. You can find the ambiguous case, which is, the acute and the obtuse situation. Whereas if you just plug this into your normal calculator, like a scientific and all, you'd only get one answer, which is the 44.43. So we're moving on to the your turn now. Can you figure out this one, please? So pause the video, work through this, see if you get the same answer, and press play to confirm your answer. The your turn starts now. So first thing, let's label our triangle. And then we're going to use area is equal to half BC sine A is equal to half. And let's label area is 10. And B, in this case, is 9 times by 0. I got tripped up there. That's going to become 7, right? 7 millimeters. Nearly got me there. Nearly got me. Okay, 7 times by sine of x. Now, I'm a bit lazy in this case. I'm just going to use my ClassPad. Okay, so I go shift equals for solve. 10 is equal to 0.5 times by 9 times by 7 times by shift 1 sine of x, close bracket. Now we need to say given that, right? So we go into Maths 3, that's the given that button, given that, and it has to be in between, x has to be in between 0 and 180 degrees. So we get the answers of 161.49 or 18.5. Okay, 18.51 degrees or 161.49 degrees. Okay, so hopefully you got that answer there, and that's our video for using non-right angle area to solve the unknown angle.